Welcome, guys. This is a backup plan just in case I don't make it to the first few minutes of class. You guys can maybe get started on some notes. I do have like a union meeting today, so I think I'm getting back around the start of 8th period, so I should be able to at least help you guys. But just in case, got you guys a little video. Today we're going to go through a couple of these drawing conclusions where yesterday we kind of were given some if statements and we decided, there's a then that can come with this. If something is a midpoint, then I know that this is going to happen afterwards. Today we're going to continue that, but we're going to start making a couple different links in the chains. And specifically today also we're going to be talking about some of the connections that we make with vocabulary and the definitions of them, and use those as logic and reasoning points to make, I guess, our statements true, to validate them with some proof. So today I'm going to start off, I'm loving the color schemes that we got. These first examples are more so just examples of the chain rule. And what I mean by that is I'm going to treat these as if we were going to treat those word problems, where we start off with some statements and I'm going to highlight all the letters that are the same. For instance, I only see one A. I see two T's. I'm going to color those as the same. And then I see one letter M. And what we're really looking at here is we're trying to repeat the chain rule realistically. Unfortunately, I do notice that I have two of the same colors on this side. Unlike the if-then statements, congruent statements can be written either direction. That's the same as saying 4 plus 3 equals 7 or 7 equals 4 plus 3. You could flip-flop both of those sides at either time and those statements are going to remain the same. So what I'm going to do is I'm just going to take one of these statements and I'm going to flip-flop it. It really doesn't matter which one you do. For example, I'm just going to do the second one really quickly. If I was to flip-flop this, it would be angle T is congruent to angle M. And I'm going to come through and just make sure I highlight those again, those similar colors that we had earlier. And then once I do that flip-flop, I do kind of like to cross off the original one so we can see just the two problems that we are given. And guys, from here, the chain rule kind of starts working. If I at least move this so we can see these kind of stacked on top of each other, I do now have the orange on both sides. I have a red on the left. I have a yellow on the right. I think we can do our chain rule. If we were going to look at this from left to right, I started with red. According to that statement, my red got me to the orange. And then according to the new statement that we just wrote, that orange got me all the way to the yellow. So because of these here, I know that I'm creating this chain, and I can honestly just throw these letters in here. I've got angle A is right there, angle T is here, and angle M is right here. According to our chain rule that we learned earlier, we know that we can bypass the middleman and just say straight away, hey, I know that the red and the yellow are actually probably going to be congruent. If I have angle A congruent, then I know that angle M is going to be also. And the way that we write this, we just say angle A, I know that you are congruent to angle M by this crazy thing called the transitive property. AKA, and this is the easiest way I can write this out for you guys, this transitive property is really just the chain rule. That's really all it is. We will probably utilize the word transitive a little bit more, but I do kind of think of that as the chain rule. That's pretty much what this is saying. So if we looked at our picture, they were saying, well, angle A up here, terrible name for that angle because there's technically 3 angles there, but we'll roll with it. Angle A was congruent to angle T. Then they said that angle M and T were the same, but if T already has the symbol that we see here, we just repeat that symbol. And weirdly, all 3 of those angles are the same. But the conclusion we really made was technically these two had to have been the same because of the linkage that we saw right here, formally proving those. Second one, we're going to do the same exact thing, just some different colors. I've got D, E, doesn't look like there's any others. F, G, I see 2 of those. And last but not least, E, F. It looks like, again, according to the chain rule, a blue is on the left and the right. I've got a solo green, a solo purple. They're on opposite sides, so we can jump straight into our chain right here. If I started with the green, according to the top statement, the green would get me to the blue. According to the bottom statement, the blue would get me to the purple. We've now completed our chain. It's just a matter of putting the labels inside of them now. So this one was D, E, blue was FG, and the purple was EF. So according to our chain rule, we can cut out that middleman, and we can just say, you know what, if all of these are congruent, I can technically again say that DE is congruent to that last one of EF. Similarly, kind of what we did above, if we took some of these and threw some colors on them, DE would mark congruent to FG. FG would be congruent to EF, but again, because I already have a marking on it, I would just repeat that same marking, and again, all three of those are technically the same. Chain rule is just going to get a little bit longer now. That's really all that it is. So sometimes we have 3 colors, sometimes we have more. Let's see how this one works out. I see 1 letter A. I see 2 letter B's. I see 2 letter C's. And 1 letter D. Chain rule is actually fully intact here. I've got a solo pink, a solo orange, one's on the left, one's on the right. I've got 2 blacks, 2 reds, both one on the left, one on the right. This means that we can start our chain with the yellow color, the pink color. So according to the top statement, A goes to B. B will then go to C. And C will take me all the way to D. Connect your dots, your linkage here. This just adds another middleman realistically. If I again throw in here angle A, this one was angle B, angle C, and angle D. If all of these are congruent to one another, I can conclude the first thing leads to the last thing. I now know angle A is congruent to angle D. Drawing our pictures, of course, we would see similar items here. If angle A is congruent to angle B, I've got this marking right here and here. If B is congruent to C, I'm going to repeat this marking. I'm not going to make a new one for angle B, but now both of those would have those markings. And then last but not least, angle C and angle D. And again, since I have a marking there, I can just reuse that one. All 4 of those would end up being congruent. So moving on now, we're going to start using some of these logical ideas that we just talked about up here, and we're actually going to start giving reasoning behind them. I'm going to make some of you guys mad right now, but I know this is like a huge, all this is like ridiculous to look at, but the biggest thing I wanted to point out was this one. You guys are going to have to memorize a few of these definitions, these theorems, and these postulates, aka you're going to have to memorize some rules is what you're going to have to do. That's totally fine though, because I'm going to give you some of these rules on this next page, and these will be utilized throughout most of your homework assignments and your assessments as well. So these are going to be, I'm setting you guys up for success. I'm trying to at least. Let's take a look at this. So on number 1, it says, given that E is the midpoint of SG, what can we conclude? If E is the midpoint, what we really know is that it cuts something completely in half. So the conclusion that we can come up with is that segment of SE, you are going to be congruent to the segment of EG. But then we have to state a reasoning for this. I understand that it's probably very apparent if you just say that, but again, we need some logical, fact-based proof to back this up. For this one, we're going to use definitions. Guys, this is technically the definition of midpoint. And I'm going to write that definition right underneath here. If a point is a midpoint, comma, then, notice the if-then statement of this, then it divides a segment into 2 congruent parts. That's the definition of a midpoint, and that ruling is kind of how we know that this has to be true. So again, we're going to get used to some of these, but the midpoint one is one that tends to pop up quite often. Second scenario, let's take a look. AB is perpendicular to BC. Perpendicular means I can come over and I can draw these little markings on it. What does that little marking mean though? that little marking means that it's a right angle. So my conclusion, I can say angle B, and yes, I can name it angle B because that is the only angle that I can see right there. I can conclude now that angle B is indeed a right angle. What definition, theorem, or proposal are we using here? Proposition. This is technically just the definition of perpendicular. That's all that it is. All right, well, let's write that out really quickly. If two lines or segments are perpendicular, and feel free to use symbols in these. You don't always have to write out every single one of these. It's kind of nice. We're not in English class. I don't need complete sentences, but I need them to be able to be read in complete sentences. If two line segments are perpendicular, then they form a right angle. Pretty straightforward. So again, seems kind of silly that we have to mention this, but we're kind of setting ourselves up for future proofs in which we have to prove ourselves correct. Next up, angle WXZ. If I look at WXZ, I'm actually talking about this angle right here. And then YXZ is this angle. It's saying both of those are congruent. This tends to be the one people struggle with a little bit. I'm trying to figure out where they go from here. If you have two congruent segments or angles like this, what it really means is says, hey, this line is kind of cutting the larger angle perfectly into two congruent pieces. What that means is that line segment that we have called XZ, we know for a fact that XZ is a bisector. It cuts something in half. Now remember, bisectors, we can cut angles in half, we can cut segments in half. It's just a variation of what we're kind of given. So the definition that we are using, we're going to use the definition of a bisector. Let's do of an angle bisector, because we do have the other bisector as well. Reasoning for that, if a line slash segment cuts an angle into two congruent parts, comma, then it is an angle bisector. All right, we got that in the books now. We can go ahead and utilize that at a later point. Let's see the fourth one. We've got two more after this. So our fourth option coming down here, they're saying MO is going to be congruent to OR. They're also saying that MO, which I've already used this symbol so I can reuse it, is congruent to MR. Ladies and gentlemen, this is the chain rule. So if I go ahead and highlight these, I see two MOs, I see one OR, and I also see, oops, I don't think it's going to show very well. I also see one MR. Some people do like to see these like stacked on top of each other. So I'm just going to rewrite these real quick off to the side so they're stacked. MO is congruent to OR. And then underneath it, I'm going to write MO is congruent to MR. I'm going to give them their same exact color schemes. MR was red. MO was pink. And OR was black. But now you'll notice, according to our chain rule, if we look at these two, unfortunately, I have two of the same colors on the left-hand side. We're going to use that process again, where if two things are equal or congruent, we get to freely flip-flop the sides for the same reason of 7 equals 5 plus 2, or 5 plus 2 equals 7. They're identical. So what I can do then is I can go ahead and flip-flop these, and I'm quite literally going to use my lasso tool to just flip-flop them. When we have this, I've got a red that's by itself on the left, a black that's by itself on the right. I also have a pink that is on the left and the right-hand side. Ladies and gentlemen, we are in business now. So if I come back and say we started with MR on the left, MR brought us to the pink, which was MO, and MO brought us to the black, which was OR. So according to this, if I fill these in, we've got MR, I've got MO, OR. I know the conclusion is technically that I can skip that middleman, and those two end pieces are going to be identical. So conclusion, MR, you are congruent to OR. Name of the proposition used or theorem, although I'd love to write the chain rule, we do have to utilize this as technically the transitive property. And that's where I was saying I like the chain rule as a layman's term, but we have to use the formal term when we're actually proving things. What does the transitive property technically mean? I can actually write this reasoning out. If two different segments are congruent to the same segment, comma, then they are also congruent to each other. And that was that idea that we saw here where you'll notice that MO was congruent to both OR and MR. That would mean by default that those two segments that we have should also be congruent to each other. So that's the definition of the transitive property. And again, you'll use a lot of these four especially throughout the process. The only difference, and you'll see in number 5, that we can technically also have an angle bisector. It would be relatively the same, but instead of cutting, we'd have a segment bisector, So instead of cutting an angle, we'd probably just replace these words angles with the word segments. And you will again see that in this next problem. Let's check it out. Last one. First off, WZ is going to bisect VX. Be careful with this. This is the one that is doing the cutting, and this is the one that is actually being cut in half. So if I cut VX in half, I'm really saying that there are two pieces right here. I think there's two conclusions we can call from this one. One conclusion that we could do is we could say technically VW is going to be exactly the same as WX. I also think it would be fair to say that W is the midpoint. Both of those we can conclude from the information that was given to us. Definition. This is another definition of a bisector. Only difference from before, we are bisecting segments this time. So once again, if a line/segment cuts another segment, or just a segment, into two congruent parts, comma, then it is, and I guess we wouldn't call it a segment bisector. We would just call it in general just a bisector. Nice. And again, the only thing that really changed from our definitions of these so far was probably just this word segment, and then we replaced angle bisector with just bisector. If you wanted to put the word segment here, you are more than welcome to do that, but it's just not a requirement. And then last but not least, let's go with green for last. Final conclusion is going to come from the second statement that we see here. Z is going to be the midpoint of VY. So this one, we will have to use some separate tick marks. We know that they're congruent, but we don't have any information that shows us they're congruent to these. So they do deserve their own individual tick marks. Conclusion of this one, once again, I think technically If we know it's the midpoint, there's only one conclusion that we can make from this. We could technically make two. I'll only roll with one. We'll do VZ is going to be congruent to ZY, and this one we've already seen before. That's just the definition of a midpoint. This one we can copy directly from what we had above. If a point is in, what was that technical definition of this? If I want to write, repeat it. If a point is a midpoint, then okay, that was mine. If a point is a midpoint, comma, then it, what was the exact phrasing? Divides a segment into two congruent parts. Awesome. So again, these notes here are just kind of backup plan just in case I'm a little bit late for class, so you guys can at least get started on your notes, and then I should be able to come in and help you guys finish those off. And then after notes, we will go over our quizzes today, so get ready for those, and I will hopefully see you guys soon. Take care, guys.